In this video, we're going to look at how to use factoring to solve equations of higher degree. For example, here we have x to the third in this equation, and so we cannot combine all the like terms to get a single letter x to get x by itself. So what we need to do is we're going to have to use factoring, and to turn the equation into this format, something times something equals 0. Maybe possibly we will have 3 or even 4, but the left hand side or the one side has to be all multiplications, so times and times and times, and the other side has to be a 0. So currently this equation, we do have one side equal to 0, but on the other side we don't really have the multiplications we need, so we have to turn this expression into a product of factors, and this process is called, so how do we turn this to something times something, we don't know how many yet, and something maybe and equals 0, we will use factoring. All right, so let's focus on the left-hand side. I'm going to do it over here. 5x third minus 125x. First of all, notice that when we do factoring, we always start with GCF. So we have 4 types of factoring, GCF, and then if there's no GCF, we count the number of terms. So 2 terms, that would be difference of 2 squares. 3 terms, that would be trinomial, possibly trinomial. And if there are 4 terms, and we may try grouping. So it doesn't matter how many terms we have, we always check GCF. And notice that 5 and 125, they have a 5 in common, so we're going to pull out a 5. And x third and x, they have x in common, so we pull out of x. Now let's divide both of them by the GCF. See, after we pull them out, what will be left? So now 5 cancels 5. X third divided by x, that's x squared, minus 125 divided by 5, that is 25, and x cancels x. So after we factor out 5x, so I'm going to go ahead and maybe put the 5x here. And the other one we have so far, we have x squared minus 25. But notice that x squared minus 25 has a square, so maybe we can break down that square into x times x. And since we already pulled out the greatest common factor, so we wouldn't have any greatest common factors anymore. So we're going to have to check the other 3 types. Now let's start with, we count how many terms. So apparently we have 2 terms, x squared and a 25. So that possibly could be a difference of 2 squares type. And so let's check. If it is, we factor. If it is not, we stop here. So we see that we do have the difference when we do have the 2 squares, because 25 is exactly 5 squared. So now we have this 2 requirements we need for difference of 2 squares. So first of all, difference. Secondly, 2 squares. So now we apply the difference of 2 squares formula, and to break down x squared minus 5 squared. So we have, since we have 2 copies of x, so 1 in the first box, 1 in the second box. We also have 2 copies of 5, 1 in the first and 1 in the second. Also, we need to generate this minus using multiplication, so we have to make sure 1 is plus, the other is minus. So we're going to move our answer here. And you could just work all of these steps here directly when you solve the equation. So what I just did is I break down x squared minus 25 as x plus 5 and x minus 5. Now the right hand side, we bring it down. Okay, so now we got the format we need. One side is 0, the other side is all multiplications. So now we can set each box equal to 0. So 5x, x plus 5, and x minus 5. So we're going to set 5x equal to 0, x5 equal to 0, or x plus 5 equal 0. So now we're going to solve for our x. In the first case, we reverse multiplication. So we got x equals 0. In the second case, we divide by 5. We got x equals negative 5. In the third case, we add 5. So we got x equals positive 5. So we have three solutions, 0, negative 5, and 5. Again, a good tip is if the highest exponent is 3, and most likely we are going to have 3 solutions. Actually, we will have 3 solutions. All right, so now let's look at another example. And so same thing, first make sure one side is 0. We do have one side is 0. And the other side, we need multiplication. So we're going to use factoring to turn left side as to something times something. Okay, right hand side we keep it equal 0. So the left hand side, first of all, 6, 5, 6, they don't have anything in common, and so there's no GCF. Secondly, when I count the terms, we have 3 terms, so that's trinomial type. So for trinomials, we do 3 steps. Draw a 2 by 2 box. So first we break down 6. That will be 2 times 3. It could also be 1 times 6, but I'm going to try 2 and 3. X squared times x squared. X squared can be broken down as x times x. Now we're going to have to break down negative 6. So I broke down this. Now I'm going to break down negative 6. Now negative 6, again, 6 can be broken down as 2 times 3, but I'm going to put a 3 here and a 2 here and make one of them negative because we have to get negative 6, so only negative number times positive number will give us a negative. Now all I have to do is to cross multiply. Now that gives me 4x, and it's a positive 4x. And the other multiplication gives me negative 9x. So when I combine them, I end up with negative 5 plus 4, negative 9 plus 4, that is negative 5x. It does match the one in the middle. Okay, so again, maybe you have tried the other ones. Those other ones will not give us negative 5, so eventually you will find the correct pairs. So now let's put the answers here. 2x minus 3 times 3x plus 2. Okay, so now we can set each parenthesis equal to 0, each factor equal to 0. And in order to get x by itself, we're going to have to do reversed operations. So add 3 and then divide by 2. So that gives us one solution, 3/2. Now for the second equation, we have to subtract 2. And we got 0 minus negative 2, it's negative 2. And divide by 3. So that gives us another solution, which is negative 2/3.